Good day, students. Today we are going to talk about percentage yield. Percentage yield. You have a factory. You have a factory. You want to manufacture a particular product. You say, okay, I am going to get, or you call the engineer, the chemical engineer in your department or the production engineer in your factory. Please, let's make calculation. I have this amount of money this year and I want to invest into this. I want to make a lot of this material. What do? I want a big yield. So can you make some forecast? Can you forecast? Can you calculate something? Can you predict how much will come out from this material I'm going to purchase, from this raw material? Because every industry, for you to make a product, you need raw material. For you to make a product, you need the machinery to put this raw material for the product to come out. You start, you spend money to buy the raw material, you spend money to buy the machine, you spend money, you put the raw material inside the machine, and the product rolls out. As a businessman, you want a big profit. The higher the profit, the better for you. You stay in business. You call your engineer or your production engineer or your chemical engineer, please can you calculate for me? If I buy this amount of raw material, how much am I expected to get? How much product am I expected to get? Then the engineer calculated raw material. If you have this raw material, you are going to get this product. From his calculation, theoretically, from his theoretical calculation, useful product now. The useful product now. This is what you are going to get, the product you need. This is what you are going to get of that thing you are producing, that thing you aim to produce. We are not talking about the waste. My aim now is about what I'm producing. How much of it am I going to get? Because that's what is going to put money in my pocket. I have spent money to buy the raw material. So if you use this raw material, how much am I expected? How much product am I expected to get? Because it is the product I'm taking to market. I am not talking about the waste product. I mean my desired product. Then percentage yield comes into play. Percentage yield. How? The raw material, your engineer goes into calculation. Your production engineer calculates. And it tells you, boss, you are expecting this amount of product if you put in this amount of raw material. What he had just said is a prediction. It's theoretical. It's a theory. We call that theoretical yield. Theoretical yield. Theoretical. That is the yield means product. What comes out? Your product is your yield. Your desired product is the yield. Yield is the desired product from a chemical reaction or from an industrial reaction or from an industrial production. So this, the desired product, the product you aim at getting, is your yield, not the waste. So the theoretical yield is what that man has calculated. You are happy. Oh, I'm going to have some money. Look at what I'm going to get after this production. Look at the amount of product I'm going to get. Maybe he told you, you are going to get 1,000 tons. 1,000 tons of the product. Wow. You are so happy. You have started calculating your money. What are you going to do with your money? You calculating your profit. This is theory. It just theorized. It calculated. However, when the production starts, certain things will happen. Certain things may happen. All the reactants may not fully react. All the reactants may not fully react. Therefore, product will be reduced. Some of the reactants may have impurities. So what he calculated will be less. The real thing will be less than what he has calculated. Product will reduce. Some of the chemicals may be lost during transfer. During transfer, some of them may be lost. During transfer, if it is something you need filter paper, some may stick to the filter paper. When you are transferring some drops on the floor, no matter how careful you may be, some stick to the container. No matter how careful you may be, during purification or separation techniques. And reactants may contain impurity, as I've told you. There may also be some competing reactions. Some reactions may be competing within your reactant. Some reactants may be competing. If you have impurity there, and some of those impurity react, maybe you have raw material A plus raw material B to give you product C plus D. Raw material A has an impurity which can also react with raw material B. So the pure raw material A is reacting with B. The impurity is also reacting with B. That's it. A what? A competing what? Reaction. So you may have competing what? Reaction. If you have a competing reaction, it will not yield your desired product. So the yield will be reduced. The product will be reduced. Now, this hinders the process under consideration, and reaction conditions may not be perfectly maintained. You have your condition for this reaction is staying this atmosphere of pressure, this degree centigrade, this catalyst. It may not be perfectly maintained. It may not be perfectly maintained. You are not there. The workers are there, and they are not perfect. So these conditions may not be perfectly maintained. So if it is not perfectly maintained, you don't get the maximum you are supposed to get, you have calculated. So all these 5 reasons causes your product to reduce. So we now say the theoretical yield is going to be lower. So what we are now talking about is the actual yield. Yield is the desired product. Yield means the desired product from a chemical or an industrial production. This yield, your manager theorized, or your engineer it calculated in theory. He got what we were expecting. You are already happy, celebrating. This is what I'm going to get. But you don't know. You did not think of unforeseen circumstances. Unforeseen circumstances. You didn't think of this. These 5 factors, or more that you can think about, that all reactants may not fully react, some chemicals may be lost, reactants may contain impurities, they may be competing reactants, and reaction condition may not be perfectly maintained. So we may not get whatever the full thing it theorized. What we get is the real thing called actual yield. The actual yield. Well, you now go back to after production. The man came, the owner of the company. Okay, you got the things ready? Say, sorry, sir, we did not get as much as we thought. We didn't get as much as we calculated. Why? This is chemistry. Please don't raise this hope. As a chemistry student, you know this today. Don't raise the hope of the owner of that company. Don't raise his hope. Tell him, this is what we have calculated. It is called theoretical yield. But what we are expecting is surely going to be lower than theoretical yield. It is called actual yield. What will we get? Will surely be lower because of what? Because of this, and some other ones that you can think about depending on your industry. So our theoretical yield, our actual yield is actually going to be lower than our theoretical yield. So because it is lower than what we have suspected, or what we have planned for, or what we are expecting, so the man will now say, okay, how much or how many percent of what you told me did you get? What did you tell him? The theoretical yield. What percent of the theoretical yield did you get? You will now say that is what you call percentage yield. The percentage is asking you now, what percent of the what? Theoretical yield you told me did you get? You will now calculate that percentage. That is called actual yield divided by theoretical yield. Actual yield divided by theoretical yield. So you say divided by theoretical yield. Multiply by 100%. So, because this is what you told him before, so what you are getting now, divided by what you told him, multiply by 100%. We are saying the percentage yield is never 100% because actual yield is always lower than theoretical yield. And why is it lower? Because of these factors. The actual yield is always lower than the theoretical yield. That is, the percentage yield is never 100% because 1, 2, 3, 4, 5. I want you to write those. And write the formula for percentage yield. Percentage yield is actual yield divided by theoretical yield. Or you say experimental yield divided by theoretical yield. Same thing. Multiply by 100%. Then you write the reason why percentage yield is never 100% or why the actual yield is always lower than the theoretical yield. You write these points. Then we can now go into some calculation. Carbon disulfide reacts, these are examples, reacts with 80 grams of chlorine to produce 38 grams of tetrachloromethane or carbon tetrachloride. This is called tetrachloromethane or carbon tetrachloride. Now, we have carbon disulfide reacting with chlorine and CCl4, carbon tetrachloride or tetrachloromethane is formed. First thing we need to look at is the ratio is 3:1. That is, for every 3 mole of this, 1 mole of this will be produced. So this 3 mole of that is what we have in a natural equation. So 80 gram, what's the number of mole for 80 gram? We are giving 80 grams of these. We are giving 80 grams of these. And this is the actual amount you produce here. But first, before your production, before you produce this, you need to calculate how much I will produce. Let's look at that. That is the theoretical yield. Don't forget, atom economy, you are looking for what? You are looking for actual yield divided by theoretical yield. You get the actual yield, you got it. The actual yield, you got it in that question. The actual yield, you produce this is actual. What is in theory, what are you going to produce? Theoretical yield, what is your theoretical yield? That is what is your expectation, assuming you did not know this. Assuming this was not known. Before you perform the experiment, you calculated, okay, I'm expected to get this. What is that theoretical yield? So 80 grams of this gives you what? We say Cl2 to CCl4 is ratio 3:1. So 80 grams, N equals to M over MR, and this is equals to 80 divided by 35.5 times 2, which is 71. Your answer here is 1.1 mole. If this is 1.1 mole, this is 1/3 of it has to be produced here. That means N of this will be 1.1 divided by 3, which is equal to 0.37 moles. 0.37 moles. Or 38 moles. Let me get that. 1.1 . 0.37 moles. I'm actually correct. Now, you know the number of mole, but when we are saying the yield, we mean in grams. So what is the gram of this? So we say N equals to M over MR. So 0.37 equals to M divided by, what's the MR of CCl4? This is 12 plus CL is 35.5 multiplied by 4. So this gives us 12 plus 35.5 times 2, that is 71, times 2 again, that is 142. 142. So 35.5 times 4 is 142. 142 plus 12. 142 plus 12, this is 154. 154. 142 plus 12 is 154. So divide by 154. So M equals to 0.37 multiplied by 154. Before the experiment, you were expecting to get this from 80 grams. If you get 80 grams of this and you assume everything will completely react without mistake, ideal, perfect reaction, without any mistake, perfect condition, perfect everything, you should get 0.37 times 154. 56.98 gram. 56.98 grams. So, which is about 57 grams. 56.98 gram. 57.0 grams approximately. 57.0 grams approximately. So if you have 80 grams of this, that is what you have. In theory, what you are expected to get is 57.0 grams. In theory, what you are expected to get. But the question is saying, you didn't get that. You produce this, which you know surely will be lower. If what you are looking for, if what you're expecting is lower than that one, you know you are wrong. Check your calculation again. It should be higher. What you're expecting should be more than what you get because of those 5 reasons I gave you before. So, and more. So our percentage yield, of CCl4 equals to actual yield, which is all actual yield of CCl4 divided by theoretical yield, which is always more. Times 100. Please, sometimes we keep forgetting that 100, don't forget. So this is equals to our actual yield, which we have in the question that we actually made 38 grams, and what we got, what we're expecting, we're expecting 57 grams. So 38 divided by 57 multiplied by 100%. 38 divided by 57 multiplied by 100. 66.6666, that's about 67%. So our answer is 67%. So this is our yield. You see, we will always get lower. We cannot get 100% yield. We cannot get 100% yield. So now number 2. In the production of iron, 49 grams of iron oxide Fe3O4 reacted with hydrogen to produce iron. If the yield of iron is 78.25%, how many grams of iron is produced? You know the equation here. I'm going to carry forward the equation. Oh, I have it here already. Now, from this equation, this is our raw material, and this. But we're concerned about this because we're given a data about this, and this, we're given a data about this. This is the yield we are talking about. The desired yield. The yield we want. That's what we consider. The raw material that we really spent money on we consider this raw material. And the ratio here is 1:3 in mole ratio. So what were you given? You were given 49 of this. 49, and you don't know how much of that you will get. So N here equals to M over MR. So N is 49 divided by MR. This is 56. Iron is 56 multiplied by 3 plus oxygen is 32. No, sorry, it's 16 multiplied by 4. So I have 56 multiplied by 3, bracket open, 56 multiplied by 3, bracket close, plus, bracket open, 16 multiplied by 4, bracket close. My answer is 232. 232. So 49 divided by 232, 49 divided by 232 equals to 0.2 moles. 0.2 moles. The least significant figures there is 2. 0.21 mole. 0.21 mole. 0.21 mole. 0.21 mole. If this is 0.21 mole, what will be this? Of course, multiplied by 3. And here will be 0.21 multiplied by 3. 0.21 multiplied by 3. .63. So this is 0.63 mole. This is the number of mole you are expecting here. But I need the mass I'm expecting because you're calculating mass. So N again equals to M over MR. 0.63 equals to M divided by MR of iron, 56. Please don't multiply by this, don't please, just 56. So 0.63 multiplied by 56. 35.28. 35.28. 35.28. 35 grams. So I have 49 grams of the oxide of iron. In my experiment, I'm expecting 35 grams of iron. So this is my expected or theoretical yield. That's my expected or theoretical yield of iron. What did I get of iron? I don't know, but they are telling me the percentage. And I know percentage yield equals to actual yield divided by theoretical, yeah, multiply by 100. Please don't forget this 100. And you were given the percentage. For this, we were given the percentage. And you have calculated the theoretical. What you feel you should get. You are now looking for actual yield. So, percentage you are given from the calculation, 78.25. 78.25 equals to your actual yield, which you don't know, your theoretical yield is 35 multiplied by 100. check that again, 35. So you don't know the actual yield. 78.25 multiplied by 35 divided by 100 equals to actual yield. 35 multiplied by 78.25 equals to that divided by 100 equals to 27.38 grams. 27 grams. This is equals to 27 grams. You can see that your actual yield is lower than your theoretical yield. What you calculated, what you were expecting to get is higher than what you got eventually, because of those 5 reasons I told you at the beginning. So with these two, one of them I calculated the percentage yield, one of them I gave you the yield and I will look for the actual. I gave you the percentage yield, I look for the actual yield. And you may be asked to calculate the theoretical yield, you will be given these 3. It's just a matter of algebra, moving things around. So, students, my next class I'll be talking about percentage purity. Percentage purity, how pure a sample is. Till we meet, if you have any question, do not hesitate to send your question to me, and I will reply you with another video custom made for you. Good day and God bless.